All right, so we have some of this stuff here, and then I think we are basically moving on to do some other stuff. So a value f, e1, e2 merely describes a computation that uses operations from the effects. We need to handle them. Each handler in this setting takes care of one of the effects. To make things simpler, let us begin with one of the simpler effects, reader, which provides one operation, ask. All right, so we got data, reader, rx where, ask, reader, r. Oops. Okay, so I think this x just describes which the other monad, I suppose, something like that. Okay, so we're gonna write this function. And it's like, this one's supposed to be like the inverse of inject, so remember, what's union? Union, yep. Union. Union rsx fx. This y. Alright, so we got some projection function apparently. We have an injection function and a projection function. So it says it's customary to call the handlers after the name of the effect. In our case, run reader takes an f value that contains reader and strips it out. We then have one fewer effect in the list. The rest of them are handled further. Okay, so run reader rf reader r rs a frsa. So it's like stripping off a reader effect. So a pure is just a return, and we have some loop function for an impure. I'm guessing that we're gonna get a right or a left. Oops. Left. This issue here. Oh. We just drop off that little m there. Unnecessary. The m describes the effect. Okay. You should think of run reader. It's a function that takes messages from a queue, handles some of them, and dispatches those that are for reader requests. This handling keeps going until there are no more messages. For that reason, the impure branch always contains a loop recursively. Well, always, so loop, loop. All right, so we need to think about this a little bit. So this pure comes from freer. And this is going to take an F reader A and an F is just a union wrapped in freer. You see there's kind of a lot of indirection here. This, that. So is that dot inject. This is very confusing to me. So, see if I can reread something about this and that. There's probably some explanation that I missed about this. Because it's kind of a weird name. But I don't remember where it is. Union. Where did it go? Okay, here we go. So there are two constructors that tell you whether you are in the right position in the list, or you need to look further. So it's either this or it's continue. So that takes a union and returns a union. What is this F here? Where does this F come from? Yeah, I don't understand what this is doing for me. What is this little guy? This stuff is really hard for me. I may have reached a point where this book makes no more sense. What's up, Illusion? How's it going? I'm having a real hard time understanding what's going on here. So like this one to me looks like we're parameterized by this function. But where does this f come from? What f is this? This f is, I mean, this f, right? I presume so. My stomach hurts. But what is this f? Because it looks to me like we're taking off, somehow taking off the head of the list, or is this implying that like it's not like it's removing this f, right? The union is still the same rs. I don't understand. I don't understand this. Yeah, that's correct, Lumi. So like this, what does this even mean? To me, this looks like we're taking whatever this f is, because it's some sort of functor, or well, no, it's something with kind star star, and we're putting it in front of rs. But what is this f here? This rs is whatever it was before, but what is this f and where does it come from? I don't understand what that is. How do I Google this? Okay, so this is a little different because it takes a strict word and the T. Yeah, see, like this is this R. What's this T? Unfortunately, I might need to use the bathroom. I don't understand what that F is. What does that mean? Okay. I don't fully understand. Here we go. Okay, sorry about that. All right, so we're talking about what this F is. So to me, this looks like building up a list. But what is a union again? Well, this is a union. So is this RS just an empty list at first? Like, how do I put anything on the list? Can I just make one? I think we need to play with this a little bit, I guess. Like, I presume that I can't, like, derive show on a GADT, right? I mean, this is a function. Okay, whatever. Let's try figuring this out. So like can I mean, I can't possibly show that, right? And what's this RS0? This is the part I don't understand. Yeah, it's a type of a list, and it's putting it in there so you can work with that on the GADT type level. So, okay, so what if we, okay, so we basically just want to probe types. And if we say, I don't understand what these things are. Yeah, like these are just existential types, but so it's like if you hit, this is just some existential. That's what it is. Okay, that's useful. So this is, but how do I like, okay, so I'm going to pattern match on this. Nope. Okay, so I'm going to pattern match on this or that to do something, right? That's the idea. So at the type level, something like projection means I don't think I can. Oh, that's okay. Well, I'll just type it. So this is like popping the F off the stack. But what I don't understand here is how, I mean, aren't we implying that this F has to be an either? Because we can do right and left? I don't understand how this works. Because doesn't this F, it would have to be either, it would have to be a partially applied either. What's up, Pretz? It's only implying that the existential that's encoded within the union has a type level cons in it. Oh, this type is FX. That's the thing that's confusing me. Let's call this something else. I know that it shouldn't confuse me, but it does. This T itself is FX. Because why? Because it's a this. Yeah, there's a lot going on here, and like I just started writing this yesterday, when was that, on Tuesday? And now I'm like going through it to make sure I understand what's going on, and it turns out that I don't have a dang clue. Because I don't understand what this so it's like some existential F. Yeah. This is like, why again can I pattern match on this? And why does it contain an FX? I'm very confused. Super confused. Okay, let's read this again. Okay, so it's, we use a single monad called F. That is parameterized by a list of allowed effects. Those effects correspond to sets of operations in a similar fashion to the sets of instructions. Computations may request the operations by sending messages, which are ultimately turned by handlers into actual work. The handlers define what to execute per operation. Okay, I don't care about the handlers so much. So these are messages. Me neither, Illusion, so I don't have a clue. I'm very confused. There's like a bunch of existential things in here. I mean, both F and X are existential. The only thing that's real is this RS, right? This doesn't make any sense to me. Maybe using them will make sense. I'm wondering if I should just continue and like maybe it will start to make sense when we use them. But like I have a feeling that it's not, to be completely honest. Let's just keep going and see what happens. So it's like this thing is a handler, and when it receives the message done, it is done. If it receives the message it's not done, then see what it is. If it's a, what is this one? If it's a right. If it's a this, loop by applying K. What's K? Jesus. Oh, yeah, that's super easy to read. Well, anyway, we have our A, which is an R, so we're taking some R and converting it to R and converting it to some other value, A1, basically, I guess. Or we have a that, which means we need to continue. Like that's our... What's a bad strategy? Oh, to just keep going and hope for the best? That's usually what I do sometimes. We did that with the dependent or the type level book sometimes, and it did actually help, I think. Like I didn't, although I feel like I was able to figure out the entirety of that book, I think. Like I think I comprehended that book, but I'm starting to get to the point where I'm losing my ability to comprehend this book. But as I told you last time, I'm really stubborn. Anyway, so like this left means, I think it means that we're not done yet, or we haven't found the reader yet. Like I'm wondering if that's what it means. Like you need to continue through the type level list until you find the reader, something like that. But how does this ensure that there's a reader? Because it takes an M. Yeah, I do. It's oop, there. But not all of it's on GitHub because I haven't committed this code yet. So it'll be the rest of this will be on GitHub when I commit it. But I can it'll be there to after we're done streaming. Let's keep going. Let's keep going. So you should think of runReader as a function that takes messages from a queue, handles some of them, and dispatches those that are for reader requests. This handling keeps going until there are no more messages. For that reason, the impure branch always calls loop recursively. In fact, impure is where all the magic happens. Remember that in the freer monad, an impure value is made of an instruction and a continuation. The first thing we do by using the projection, this one, is to check whether a request is intended to be captured by runReader. If that is the case, indicated by a write value, then we do our job and call the continuation. Yeah, see, that's exactly what I said. I mean, that's... Yeah. I think I understand what the point is. What I don't understand is the machinery behind it. Like, I don't fully understand this whole business right here. especially these pieces. This function is not so bad once I changed this value from x, because for some reason I was thinking that this x and this x are the same, and they are not. They're very different. So I just wanted to change their values to something else. And these two things are different than each other. That's an fx, and this is a union. So somehow that is saying, like, keep going because you haven't finished. And this is saying you found the thing you need, so do something and then continue. So it's like this operator is somehow saying if you see a reader, run reader. And I don't know how we're going to link these two things together, but I presume somehow we're going to link run reader and all the other handlers together and do something? I don't know. I don't know yet. We'll get there. Okay, so we've read that part. So a left return value from proj, I'm just going to call that, I'll call that project, from project, this one, indicates that the message uses another effect different from reader. In that case, we leave the operation untouched. We return another impure with the same op, but modify the continuation slightly. Oh, we're probably going to have... That's what it seems like. Yes, Prutz. That's what it seems like. But I'm wondering if we have like some sort of dispatching function that basically just ensures that we're running reader without this looping. Yeah, so like that's the thing that's confusing. Like how do we ever hit this? I don't know. That part I don't know. We'll have to see. That's why I'm saying I think we need to keep continuing, because yeah, it looks to me and also to you that it's on the head, right? But why, if there is in fact a reader there, why do I have to do this business? Like, because it's, again, I don't understand fully this and that. Maybe we'll have to do some Googling for some of the posts from other people about this stuff. Okay. By repeatedly calling handlers, you reach a point where you have exhausted all the effects. This is visible in the type of the computation f empty list a. Since there are no effects, that computation can be turned into a pure value. So they point out that you can't do an impure here because there's no effect to create a continuation with. Member. Maybe. So yeah, this loop function takes this though. Like this is the input to the loop function. And if this is truly a type level list, although maybe we're thinking about it incorrectly, let's look at F again. So it takes the R off, but then it recurses. Oh, right. Yeah. So it has to keep going. You're right. But why does it have to keep going? That's the part I don't fully understand yet. That's why I think we need to keep going, because there's probably going to be a link to saying why are we looping? Like, what's the whole point of that loop? Because I don't know yet. Okay, so the handler for reader effects is one of the simplest. In general, running a handler changes the return type. Here are the signatures for handlers of state, error, and I don't know what non-det means. Okay, let me put these in here. Run state sf state s rsa f rs as. So it looks a lot like the state function, not surprisingly. Run error f error e rs f rs either ea. I feel like we're missing an a there. Oh yes, we are. It goes here. Yeah, that's what I would guess too, Strigger, but I just haven't seen it before, so we'll see what it means. They might say what it is as well. Also, hey, how's it going? Yeah, I'm not entirely sure yet. The looping part, I'm not entirely sure about yet. Oh, by the way, these are in, if you care to go look, these are in freer simple. Non-det rs. That's interesting. That's a pretty interesting function right there. Okay. There are in fact a lot of commonalities between these run functions and corresponding functions used with monad transformers. For reference, anyone relatively new, I don't normally read this much from the book, but I feel like if I miss something, it's gonna be like I'm already confused, so I want to make sure I read more carefully than normal. Okay, so usually after executing all your effects, you end up with a type like either string list of int, which indicates possible failure and non-determinism in the answer. In a similar fashion to monad transformers, the order in which you run the effects determines the final outcome. An interesting feature of the Extensible Effects framework is that handlers are not required to completely remove one layer of effects. They can transform one effect into another, or even keep the list of effects untouched but do some work inside. Okay. An example of the former, transforming one effect into the other, is given by the following handler, which instead of removing all reader effects, which is what this is doing, this is removing all the reader effects from that list. Two main reasons I dislike Haskell are compile times, which are slow, and monad transformers, which are hard. So, yeah. It looks like this whole idea of extensible effects frameworks is not fully figured out. Like, one has not beat the other ones. So we'll have to see what happens there. Like, what happens in the next few years, maybe, to see when okay. So what are we doing with this one? An example. Okay, we're gonna transform one effect into another, apparently. call to ask is turned into a call to get. Yeah, this looks like a natural transformation, which is interesting. I don't understand what I'm being shown here. Okay. What's really amazing to me is that you can do these extensible effects actually with no overhead with some tricks by, say, not representing the effects stack as a linked list. Yeah, and they don't, like, you have to write a ton more code every time you want to add a piece to your transformer, right? Like, they don't just naturally fit together. I mean, the base ones do, but not custom ones, which I assume is more popular in larger, you know, private code bases or something. Anyway, I'm not sure. Trying to understand why this is an example. I think we're just trying to prove that it's not required to remove a layer of effects. I think that's the point. So let's look at this. Run reader s. All right, so if we get pure, we're done, which means we just return x, because that's the only thing we can do, which I guess is probably a in this case. If we get impure is where we have to convert from the reader effect to the state effect and then use our continuation or something, I think is the idea. So we're gonna have like case proj a where of, I don't know why I want to write where all of a sudden. So if we get an ask, we're going to convert that to a get. So the only way we can do that is by injecting it, because we can't, like, we need to add this. We're removing this from the stack and injecting this onto the stack. So that's what it is. Like, project it out and then inject this one in, I guess is the way to think about that. Loop.k. If we have a left, we need to keep recursing. That op. Yeah. Give me a second. I gotta figure out this. Oh, I probably need to specifically write the type. That would be my guess. F reader R RS. Otherwise it can't figure out the types or something. Of like, what does inject get mean? State R RS A. We'll see if that fixes it. Yeah. So it's just got to be. Yeah. So this and that. I need to think about that a little bit. I don't quite understand this yet. This, that. Oh my goodness. Okay, so in this case, we're popping a reader effect off of our effects list. In this case, yeah, it's not a particularly good naming scheme, I don't think. I wonder if even this and next would be better or something. I don't know what's a better name. In the free or simple case, I don't think they even define one. I think we just looked at that, right? Free or simple union doesn't even have a this or that. It just has a single union, which takes a strict word, which is just some bytes, right? And a TA to another union. So it's just a recursive type, a single recursive type. But there is not a this, as far as I know. By the way, I've been trying this new, well, I don't know how, it's not that new, I guess. Brave browser. So I'm giving it a shot. World peace. Interesting. That's how you get world peace, apparently. You use world peace. Yeah, I don't know where the names this and that come from. Probably they come from like the original paper that did this, and maybe that's just a poor naming scheme. So anyway, okay, so in this case, we're running a continuation, but we need to add a layer to the output type, I guess. I'm not entirely sure why. Does it compile if you remove it? I'm curious. It does not. That's kind of cool. It's the same idea in this. Let's look at the error. I'm wondering if it makes any sense. Like, I'm hopeful that it will make wait, what? There we go. So the actual type it doesn't really make a ton of sense. Yeah, I mean, it kind of looks like inject to me, like just thinking about it. But this particular error doesn't help me, I don't think. Maybe it's supposed to, but it doesn't. So, I mean, it's just dealing with the existential piece. Like, that's... Like, without it, you don't get that extra layer, I guess. Line 3. Okay, let's look at it again, because... Line 3. Do I have type highlighting in Vim? What do you mean? If the compiler doesn't work, I can't look at any of the types. I mean, I could probably stick an A here or something and look at the type maybe. So yeah, it needs to No, I can't do it with hover. No, it doesn't. It won't work with hover. It will only, like, it kind of works here, but only for holes. The um when we were using, what was that other editor we used for a little while? It was just Visual Studio Code and the Dram Forever plugin. That would give you highlighted types like automatically for everything, but I can't get that here. I don't know how to make it work. But you can see, like, we clearly need this thing, like this extra layer to make the RS piece work, right? Because these have to be the same length, and the only way you can do that is probably by writing this. I don't fully understand it, but I might have to think about it more. This is hard. This is very hard for me. All right, so after this translation, you can call run state to execute the computation. This ability of effect handlers makes it easy to create your own restrictive monad that can ultimately be expressed in terms of other handlers. What's the type of inject? It is there. Excuse me. Oh, that's why. We don't have a union. Our op isn't a union, is it? That's all it is. Wait, no, it. Oh wait, I'm thinking of something different. Sorry, you're asking for. Yeah, you're asking for this piece, but yeah, I need this one. It's the same idea. It's just this is like inject for union or something. Yeah. I mean, if you put op here, it doesn't work. So that's helpful. The error message is kind of useful, maybe. Let's read the error message one more time, because this is really hard. So this is pointing at loop.k. I think maybe part of my issue is that whenever I see this, it's usually pretty hard to figure out like why it's this way. And also we're seeing both layers here, right? We're seeing our freer and our F, which, oh wait, well, the types are just synonyms. Yeah, I mean, it's tricky. Although Strager seems, I think Strager understands this error, and maybe he can explain a little bit. Yeah, this is like equivalent, right? So this is like a recursive RS1 or something. I think it means like equivalent. Can be cast. Equals, okay, yeah. So somehow we're like going infinite. Yeah, I think the tricky thing is that the error is actually over here, which is kind of one of these strange recursion errors that are tough. But I'm not going to dwell on this. It's something like removing a layer versus adding a layer. Something like that, anyway. Again, it's probably one of these things we're going to have to stare at a while. Okay. So this point of view, computations request operations via messages and handlers intercept those that are targeted to them, provides a different answer to the problem of control operations, such as catch error. The problem of how to lift catch error generically required such a convoluted solution in the monad transformers arena that we devoted the whole of chapter 12 to it. The solution in this new framework is that throw error is an operation, but we have been all wrong about catch error. It is a handler. This makes sense, as catching an error is exactly like intercepting the throw error message and doing something in response. Okay. Let's discuss a simpler version of catch error called handle error. So we're going to write a handle error handler, which sounds weird to say, but that's what it is. And the only difference between it and catch error is catch error throws exceptions, and handle error has to handle the error completely, which means, I guess, don't throw exceptions. Okay. Here's a small example of that error message. What? Cannot construct the infinite type A equivalent to list A. Why is this infinite? I don't understand. So X should have type A. Is it saying that it thinks, because we're returning list of A, that A is an infinite, like potentially an infinite nested list? Is that the idea? Yeah, A is defined in terms of itself. Okay. So this thing basically is saying that you're giving me a list of infinitely nested lists. Basically. Interesting. So A is defined in terms of itself. So RS1 was defined in terms of itself. So why does that fix that problem? Because it adds the layer to make it not defined? I don't know. I don't know. Need to keep working. Maybe it will start making sense. I have no idea. Maybe it won't. Which I suppose is fine too. Less confusing? I'll take a less confusing one. I mean, I think I understand what it's doing. It's just that it's a little tricky. I mean, this is going to be the same error, right? I mean, this looks exactly the same, doesn't it? Yeah, yeah. But basically the idea is that we're somehow defining that RS1 existential type in terms of itself. And the only way we can get rid of that is by adding another layer on. I don't know how to explain that part. It's like why that is like the next one. That is like the next one. I have not. I don't know what HM stands for. HM. M. What's up, horrible cow? Your function returns an element of the list. Oh, no, I have not. Okay, yeah. I should have got that from your context, but I have not. Yeah, I know that, but the acronym wasn't. Error. That's probably true. I probably should do that. That's not a bad idea. Maybe you should do it on stream. Maybe it would blow my mind. It's entirely possible. Oh, well. That probably could also hurt my head. Can only presume that that's going to be correct. And then impure. Case project A of right error something. Do something with the error. Oh. And this is just, why do I keep wanting to write that? It's just impure ob loop dot k. Our basic continuation type function. So this is kind of interesting. Notice no recursion on error. Oh, yeah. Right, because we're returning an entirely new effect. Interesting. Yeah. And yeah, same is true on 82. That's kind of weird. Okay. $82. Yeah, it does recurse. That's what I said. Sorry. If I didn't. That's what I meant to say if I didn't. Okay. The key point here is that when we get an error message, we forget about the rest of the computation to be found in the continuation, and we turn instead to the exception handler C. Note that the list of effects RS does not change after the handler runs. The error E effect is removed from the list in handle error. Since RS in catch error contains error E. Oh, sorry, I should point this out. So in catch error, interesting. So we could permit resumption on error by passing loop K to the error handler. Yeah, so I think that for catch error, the type permits what you just said. I think. Let's look at it together. I think. So let me read this out loud again. So the error E effect is removed from the list in handle error. Since RS in catch error contains error E in every place it arises, we are allowed to throw new exceptions from the exception handler. That's not what you were talking about. Yeah, that's not what you were talking about. Yeah, so like based on the error itself, we could like start a new series of effects to deal with the problem, I guess. Okay. We have seen that when talking about effects, there are three modes of operation: injection for the smart constructors, removal for the run family of handlers, and interception while keeping the same list of effects, like handle error. That's all Scala stuff. Okay, so the framework outlined here works flawlessly until you need to perform some file system operation, random generation, network communication. In those cases, you want a handler to run in the I/O monad. The FS and random effects are prime examples. The naive approach to writing a handler for those operations leads to the following signatures, which apparently, won't run, I suppose. So F, FS, RS, A, IO F RSA. That appears to be a problem. I guess. And run random gen is essentially the same thing. So the problem is now you cannot easily handle computation that use both FS and random gen because the output of one of them is already in IO. Oh, okay, that makes sense. So we can write this function. It's just yeah, I'm curious as well. Yeah, I think we're gonna kind of write that, but we'll see. So it says both the Haskell and Scala variants of extensible effects include a special mechanism for handling handlers that run inside of a monad. The essence of the idea is to wrap such monads as effects. As a result, handling any other effect using the monad becomes a translation from the effect to the wrapped monad. In code, we introduce a lift type to wrap them. So we're gonna have, we'll deal with this in a second, I guess. Data lift MA equals lift MA. What? Why? I don't like when it does this. It's very annoying. Let's just leave this alone. It can stay like that. So then run fs. Well, we can just change the type. So a lot of times when I write a new type, I actually turn it into a record with like an unlift. But it's not really not necessary in this case. We can just do it like this and it's fine, I think. So member lift IO RS F FS RSA F RSA. Do we have the, we don't have the type or how to implement this yet. Maybe they'll show us how to implement it in a second here. In contrast to the case of computations that only used pure effects, the final type of a computation after handling all effects is not F empty list A, but F lift IO colon empty list A. This means that I should have said cons, sorry. This means that we cannot just extract the final value of a computation with run. We have to execute the monadic actions. We therefore require a different run. So we'll have run M, monad M. I really hope we start using these here in a second. That would be useful. Lift M. Oops. Return X. So right now we're basically dealing with all of the monadic actions, which there could only be one of them, I suppose. Yeah, it says error, this could never happen. Right. So loop impure a k equals case proj a of right lift a prime do not possible. Okay. Yeah. I'm probably gonna write that here. I mean, we could also just write what else could we write? Anything else? Probably not. Maybe no, because you you're not returning a lift here. I don't think. No. Oh my goodness. Okay. The only caveat to this solution is that you have to forbid more than one appearance of lift in your list of effects. Otherwise, you would not be able to execute the computation. Remember that there is no general way to combine two monads. For that specific goal, both Haskell and Scala libraries define a last member constraint that checks that a given effect is the last one in the list. Since you cannot have two different effects as the last member at the same time, this effectively prevents the wrong situation from occurring. That's it. That's the end of the chapter. So we didn't really write run fs. I mean, I kind of want to write this function, but I don't know how. Yeah, if you squint. I sort of see what's happening. Like, I see the patterns, but that doesn't mean I think so. It's just... Wait, would it? No, it can't be, right? It has to be written more like run reader, where we deal with, I think. Let me look at this more carefully. Yeah. But like, what does it do? It doesn't seem to... Okay, right. We don't have an FS type. So you need an FS type. Wait, do we have an FS type in here? We don't. So what we need is... I don't know why I'm putting it there. We would need a data FS where... No. Does it need to take anything? I have FS somewhere, but not in here. Wait, yeah, I do, don't I? Yeah, it's right there. Thank you. I'm silly. Okay. So we need to basically deal with two types of projections. How do we deal with both those projections? Oh, it's just right. Okay, well, let's try it because my brain is now obviously stuck in thinking about it. So we're going to have... Shut up, Google. Did you hear that on the microphone by chance? Sorry. Just gonna be like, okay. It didn't say anything. It's just, I don't know. E. Well, we can just say loop where loop pure x loop impure ak equals case proj a of... This is the part I'm confused about. So in this case we have ask, but here we're gonna have to have, I think, read file Does this compile? It does. Interesting. That's probably correct, though. It looks correct to me, anyway. If I had to guess. System. Let's see. We're gonna inject oh, right. I think I have multiple read files in here. And it's not loop K. It's, you may have wrote it. It's K what? Well, we don't, it's just, is it just K? So we need an either IO error string. Yeah. It's a list of car. So it's supposed to be string to, what's the string here? So in the reader, we run our continuation on our R, right? Because we're getting an R. Oh, sorry. Where's this R come from? It's our input. What's our continuation here? Maybe it's just loop K. Oh, you think it's, oh, it could be bind. But it can't be impure. It's probably inject, right? Well, we need an impure somehow, I think. How do we deal with the impure here? This whole thing can't be impure. We pass R to our continuate. Oh. I feel like we're gonna have this thing where we need to add a layer. Oh no, we can't do that. This is just saying that lift IO has to be part of this at the end of the day. All right, let's start doing some patterns here. Oh, that's a good idea too. That will help the... So this just needs to be an either It might be wrong, but it compiles. Like, it seems to me like we need to do something similar to run reader, right? So when we get an ask, our continuation needs to be past R. So I guess maybe the question is, what's our continuation function here? Maybe that will help. Yeah, I can. Hang on. Okay, it's do 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 do. Oops, that didn't work. It's here. Okay, I mean this. You need to pass something to the continuation. Is my type wrong? Doesn't look wrong. The handlers for FS and RandomGen now become translations from those effects. Translations from those effects into lift.io. Translations from those effects. I don't understand. Does this need to be run M? Yeah, it takes a little bit of time. Well, you don't need to download GHC. Well, okay, yeah, I guess you do. Never mind. I'm stupid. So, like, you need to continue. How do you... Constraints include A2, either IO string Yeah, impure is essentially bind. That's why I was thinking maybe it needs impure here, but how do I need to... Oh, I need to loop. I need something like this, I guess. Oh, except that shouldn't be an underscore. I need something like this, I think. So how do we get... Or do I need to... Oh, do I need this? Do I just need... There's no way. What? You think so? We can try it. I don't know the answer, so... Well, we'll just get try. System. I don't know the answer. I don't have a dang clue. But this seems to compile. Hooray. I mean, maybe. So what are we doing? We're injecting a lift that contains a natural transformation between a string and an either... What? Whatever the either is. IO error string. Let me say that out loud again. See if that makes sense. We're injecting a natural transformation This is hurting my head. Yeah. I guess inject here is like another. Probably not. I mean, this is going to be the same thing, right? Just with write file. Oh, these parentheses are bothering me. Oops. Yeah, that's fair. It also means I can remove parentheses, I think. Some of them, anyway. Like the loop.k ones I can remove. But I don't know. Neat. That's pretty wild. So the other question that hasn't been answered by this is, how do we actually use this thing? Which is a little annoying. Like, how do I actually build a a system of these things. So I want to, let's say I want to generate a random number and put it in a file. How do I do that? Like, that hasn't been clear to me at all. Yeah, like that's not in this chapter. Legitimately not in this chapter. So maybe what we do is we go look at here. Yeah, maybe we just define that. Maybe. Let's just try it before we look. So, okay, so we want to build a write random number, and it's going to be an f of random gen. I think it's just random gen a. A. Yeah, isn't it just supposed to be fs? Isn't it supposed to be this? It is. Okay, sorry. I was like, wait a second, you're right. But it was giving me a weird error. So this doesn't return anything. So then we're going to say... Actually, what we really want to do is write the random number and then read it, just because... No, it's just going to produce the random number, which I think is supposed to be an integer in this case. We also need to write run random. And actually, maybe we should just not run random and just write something to a file and see if it works. That's what we'll do. Because I don't want to deal with this. So what is this going to return? It's just going to write a number. And it's going to take an int. Actually, just let's keep things really simple. The contents are going to be a string. Let's start here. We want to write contents. We're also going to need a file path. Right? Okay. So is the goal here, or is the beauty of this that we can just like write do what? I mean, we're in a monad. What are we creating here? Effects. How do we create effects? We use our smart constructors. So we're going to write file. That's going to give us an effect. And then we need to compose the effects. Yeah. But I need more than that, don't I? No, I don't. I just need that and run fs and run m probably. So this is literally just supposed to be write file. Yeah, so we don't even need, wait, we do, I think. Does this compile? It does. So well, we're not going to have random, but I think we're definitely going to have this. What are we complaining about? I fixed that. No, I know we removed randomness to see if we can get this to work at all. Okay, so write file takes a file path to hello.txt. Hello? Oh, right. That says all good. Clearly not. But confused. It's right there. Okay. Why is this so unhappy? Is that really the type? I guess it is. It returned unit, so I suppose we could like pattern match on it to return the actual unit if we wanted to. Okay, so then so this is kind of silly because we're not composing effects at all. So what we want to do is compose the effects, I guess. Ugh, do we really want to do this? We're gonna try it. Otherwise, what's the point? So this doesn't need to be here. So we're gonna write random int. Actually, before we can write random int, we need to run random gen member lift io rs f random gen rs a f rsa run random gen equals loop I don't know why in these cases I'm writing a loop function, right? I can just pattern match directly. It would help it would simplify this code, right? I can literally just write. Maybe that's just to help like make it obvious, but it seems to me like we should be able to just do this, right? The only thing that's different is these become run random gen, I guess. This makes the code a lot nicer. And we could also do this. Oh, the optimizer to be. Also, hey, typed rat, it's been a while. How are you? We're trying to understand extensible effects. And I'm not sure it's working, but I'm trying. I think I sort of understand how to write these functions, but I would have not come up. I don't think I would have come up with this by myself. So Strager basically figured this out. Mm-hmm. The machinery for using them is very complicated. Like, actually using them doesn't seem so hard thus far, although we're going to try and write a random number, and we're going to see if that works. But my assumption is I'm actually going to need yet another effect in the middle here that converts an integer to a string. But maybe I just use fmap to do that. We're going to find out. Not entirely sure. Why are we going to... I don't think we're going to have to write the effect, actually. I just realized that I think it's just going to be an fmap, but I'm not entirely sure where yet. Does that make sense? Mm-hmm. I completely agree with you, but I don't know how to do it. So we'll see here in a second. We won't worry about the optimization right now because we're not testing the speed of this code. Although the next chapter is called Performance of free monads. My brain is definitely fried. There's no doubt in my mind. No doubt. Oh, we're going to just do to get the random number. Never mind. Okay, I think I get it. We'll see how it looks. What am I doing? Okay, right. What's the constructor called? I think it's just called random. So it's gotta look similar to this, right? What's the function to generate random numbers? Wrong, Hoogle. Is this not it either? Jesus. Haskell? I'm gonna get my computer hacked here in a second. No big deal. Should clearly just be called Hoogle.everything. But, you know, that costs money. I think I want this. System.random. We need funding, yeah. Random RIO, I think. But I'm pretty sure I need to do something in I've had trouble getting this to work recently. Oh, nice. Okay, it works now, apparently. So, random RIO. Pokemon's fun. Anyway, enjoy. Enjoy. Well, okay, let's do the following. Let's start here, because this one's easy. And something goes here, which I think is a... Oh, right. It's random things. That's the problem. It's like start, end. And then here goes start, end. There's no loop function. Run random gen. Run random gen. What's the type of try? I forget. Right, try is giving me an either. I don't want an either. That's not the function I'm looking for. I just want lift. I think. Yeah, the try is necessary because that thing returns an either. That's why I need try, I guess. So it's just this? Maybe? Yeah. Because it can fail, exactly. So Okay. So stupid. Yeah, I think that I mean, it could fail, but it doesn't return an exception apparently. Or maybe it can't fail that way. I'm not entirely sure. It must be guaranteed to return a result or something. All right, so now we need to make a computation, I guess. So it's like write random number between. So this is going to take a file path and 2 ints and return an f of, well, we need random gen, we need fs, and we need lift io. Um, right, I need to use type level lists, so I need to include data kinds, I guess. All right, so then in this case, we should be able to write this. We should also be able to write the following by doing, I guess, run m, run fs, run random gen, write random number between example 0 and 100. Do. Huh? Like so? What do we think? Is it gonna work? Compiled. What did I call it? Oh, just example? That was stupid. 83. $38. Well, it seems to be working. That's kind of neat, I guess. Okay, so Prutz points out, like, I don't see how it's different than from concrete monad transformer stacks. Well, in concrete monad transformer stacks, wouldn't you have things like lift and stuff here to like move around which part of the monad you're messing with? However, no need for lift, however. I haven't written that much with the, like, a lot of the monad transformers, but I feel like I remember them being a little cumbersome if you were trying to write a function like this. Yeah. I don't remember ever them being this easy. But also, like, I don't know that writing this particular type is all that easy either. Sorry, this type here. Because I think these have to be in order, right? If I put these out of order, doesn't this not compile? Yeah. So, like, you have to define your pipeline of these things in order, I suppose. And the lift always has to be last, I guess. Yeah. But again, these could be arbitrary custom things, right? That both, in this particular case, they both happen in IO, which is kind of neat. Yeah, that's true too. Is that a good thing or a bad thing? Might be a good thing. Well, I guess it needs to be a good thing, otherwise it would be really problematic. Yeah, that could be as well. Random num dot text. Yeah, me neither. I mean, I know it exists, but effects are unordered in this system. Are you sure? I'm pretty sure that if I put fs in front of here, it's gonna complain. Yeah, I think it has to happen in order. Although maybe I can write, maybe if I just flip these, it will work. I'm not entirely sure. But that sort of implies that it's ordered. Run. Yeah, so like, yeah. No, that's okay. I mean, it's an interesting thought, like, how are these two things interconnected? Because it's important. I think one thing that's useful is that using these things is particularly, like, pretty easy. Like, it just looks like pretty boring Haskell code other than obviously this component here. But this looks like pretty boring Haskell code. But there's obviously a lot of machinery happening behind the scenes. Execution speed? I'm not entirely sure. I mean, I guess all of the hard stuff is computed at compile time. But I don't actually know because there's a lot of indirection going on with the freer. There might be, maybe there's something about fusion. Is that the right term? Isn't there one of these called fused effects or something? Yeah, and the compiler errors are going to be confusing as hell. But I guess that's true with monad transformers as well. I don't know. That's, yeah. I don't think he's wrong there. Ow. This was cool. I mean, I feel like we have the sort of introduction to extensible effects, right? We definitely have not gained deep understanding of extensible effects, but we look at them and they feel like something we could understand in the future. I mean, one good thing is that we have done some type level stuff, so that doesn't scare me at all. Like, this idea didn't scare me, right? The thing that's confusing is all this existential stuff happening. Right? There's like pieces that don't mean anything, and that's confusing. And this X doesn't really mean this X, so it's like, this is very weird. It's very, very weird. What we should, I don't know if you've ever seen, I think there was Alexis King also posted something on Twitter when she was like designing her effect system of like, I think what it was is like the actual continuations between like this, that, union, blah, 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 to like try and understand how things track through the system. And maybe it makes more sense to sit down with a pen and paper and write some of these out, longhand, to try and get some feeling about how they work. But my understanding is this isn't really a solved problem yet. People are still trying to find the best way to do this. But maybe we'll try, maybe at the end of this, we should just try different extensible effects libraries and see how they behave. Like, just to see how that looks. Yeah. I do want to figure this out, though. Like, it bothers me that I don't fully understand exactly what's happening. So maybe I never will fully understand. I mean, something about this kind of made sense, right? Like, we had to deal with some layering here, and there's no layering here. Like, we're removing something here, and here we're, returning a new effect. I don't know how we actually handle errors, in the sense that I don't know how this function works. Like, I need to be able to deal with, I actually don't know. I'm not sure what that, like, they were talking about how you have to deal with every error, but I don't know really what that means. Or I guess in that case you have to recover from every error somehow. Whereas catch error, I guess you don't have to recover. I don't even think that's correct. I'm not really even sure. See, like, I'm confused. This sort of makes sense after I wrote run random gen. I feel like I need to write a bunch of these to just kind of understand what they're doing. But I presume a lot of this is going to be like, I need to do something in IO, and I just want to make sure that these things happen in order, and I want to make sure that they're easy to compose. And that's why people are using these effect systems. Like, I need to go ask for something on the network, and I need a random number, and I don't know. Then I need to go do something else on the network, but something different. Then I need to write a file. I've heard of recursion schemes before, but I have not used them. Do you think, is that one of the things that might make this make more sense? Because if you're going to say yes, then I will spend time with those as well. I have those on my list. Like my reading list right now is just like this. And there's like a ton of stuff in here that I want to read. I think Recursion Schemes is in here somewhere. Recursion Schemes. Yeah. I knew what you meant. That's okay. But like this is, I think it's actually a library that implements different recursion schemes. Is that what it is? Well, this is for Scala. So I need to find one of these for, I think I found this like nice picture and it was just useful. So this clearly isn't, although I've seen this name before. Why have I seen this name before? Slam data. They do something with... Oh, this is like the FS2 people. I feel like I've heard of something with Haskell. Data gen? That doesn't sound familiar, but... Oh, I know what it is. It was the pure script formatter. That's what it was. Where's run effects? There it is. That's the thing I want to see. Oh gosh. Sure. Looks great. I don't know what to say about it. I mean, I see what you're doing, right? But it's not. This seems quite useful. Inject.io. We would probably end up writing that a lot. So, actually, where is it defined? Oh, right there. Why is this not plussed? How confusing. Oh, maybe I'm looking at a specific commit. That's probably why. You probably had multiple commits. Yeah. If I did this, it'd probably look like that. Oh boy. Nope. No. Okay, anyway, I lost it. Is what it is. Okay. Yeah, let's get back to what we were doing. Blah, blah, blah. I mean, we did write this with some help from Strager, as seems to be the usual thing these days. So this is fine. Yeah, I don't know. I'm sad that I've gotten to the point where like I can't figure this stuff out by myself. I mean, I probably would after a while, but it's hard. Anyway, I need to. Well, it's 9:40, I guess. Started. Well, I took a little break. We should probably go to like 10:15. So I need to grab some more water. I think so. Let me grab another glass of water. I'll be right back. Yeah, they're not very good. I don't care. So one that I thought of before is Odor. So like this funny gold squirrel. That comes from our PiffSoft thing. I don't know if you've seen PiffSoft before. So Piffed Soft. There we go. So it's point free for the sake of point free. Because at the beginning, when we started doing these like these books, we used to just have like it was basically just how point free can we make our functions. That was kind of like what we did at the beginning. So there was a lot of PiffSoft. And like, yeah, point free for the sake of point free is just, yeah. How many points can you add to your function? And how many arguments can you remove? Yeah, but like, again, you get to a point where everything becomes unreadable, so don't do it. But anyway. All right, so let's keep going. Oh, one thing I was thinking about when I was walking away is like I still don't fully like I think if you told me well there's point free .io. Yeah, you can like put whatever you want in here. One thing I was thinking about as like adding is a going in both ways. So if you had a point free version, how do you make it point full? I was thinking about adding that to this website. Because I suppose you could just do a type, like just do Control T of thing, and then fill in the holes or whatever. But you gotta like normalize so that everything is A, B, C, or whatever. Anyway, it could be fun. Yeah. Yeah, like if you had something that was point free, like it would be nice if you could type it here and then go the other way. And like maybe we should just implement that. But like I think that gets implemented here. I don't know where it might just get implemented here. Like it might not need to mess around with, I might not need to mess around with this, and I just need to mess around with this. JK lol, probably not. But I'm not even sure. Also JavaScript, so like huh? It works. Why is that there? Anyway, so you just need a button. I don't know how you, I don't even know. I guess, whoops, that this SCSS thing, that's all styling. There's a main.haskell. Oh, okay. There's index HTML. So you just need to add a button. We could probably do that, I feel like. Maybe we should do that. It could be a fun little project. Or an impossible task that blows my mind and I never finish it. One or the other. Okay, so step 1 is we always do the following. Performance of free monads. And then we'll delete this crap. I mean, we can just stop if you want. I would be fine with that. My head hurts. We can wait till next time. Sure. Chapter 15. So, previous 2 chapters have a clear message. Build your own monads to bring the language in what? To bring the language in which you program closer to the language in which your problems are modeled. Bring your own monads. That's a strange sentence. Both free and freer monads take care of most of the boilerplate, leaving only the juicy bits to be developed. It's a funny thing to say, juicy bits. Unfortunately, the basic implementation of free monads does not perform well under all possible circumstances. Interleaving inspection and generation of computation imposes a performance loss. In this chapter, we review other encodings for the same concept that lead to more efficient outcomes. Oh, fun. This chapter contains more complex pieces of code. Fun. Maybe it will make more sense because it does say we're going to look at a similar performance problem in the context of lists. So maybe that would actually be useful. But I don't know. I don't really want to start this now. My head already hurts. Do I want to start this now? I don't know. Yes, I do. Okay, let's do it. So we all know what a list is, so wonderful. One of the basic operations is to concatenate them. We recurse over the left argument until we have no more elements to append in front, right? Yeah, I can do it. Church encoding and reflection without remorse. I have no idea what they're going to talk about. I think this chapter is going to be puzzles. I think you're right. So we're going to write a function, append, basically, but I want to write it, so we can't. If I recall correctly, we're basically going to have yeah, we need more pluses. This isn't Elm. Oh, no, this isn't right, is it? Yeah. We need to recurse through this side. think this is right. Yeah, we want to pop this piece off, right? That's the idea. And then that way we're only building one list. Something like that, I think. Okay. So it says you need to perform as many steps as there are elements in excess. We say that concatenating two lists takes time proportional to the length of the first list. Reversing a list is another simple operation on lists. The beginner's implementation works by concatenating. Yeah. So, no, just this. This is a terrible idea. Well, it only can take one thing, so I can't use that, right? That implies I at least have, or I have two arguments, doesn't it? It seemed, well, maybe I just am stupid, which is entirely possible. What happens here? Like, the worst implementation is this, I guess. Oh, yeah, we can. Of course we can. We have minus. I suppose this is the worst implementation. Is this the naive one? Yeah. That's what I thought. I don't know that we... I mean, it's like... How do we write that as a symbol? Do we write it with... What would reverse be as a symbol? This is how my brain feels right now, by the way. Not entirely sure. Because I don't think that would be it. Yeah. I don't think it has a symbolic. Isn't there a unary minus? No, there is not. Wait, doesn't there... Yeah, I just forget how to... Like, there's a tricky way to encode it. For number literals. Yeah. Okay. Yeah, so we don't want to do that. So the problem is the calls to concatenation are nested in such a way that every subsequent step gets a larger list on the left-hand side. Every step costs you more since the concatenation operation is linear over the length of its left argument, which grows at every step. So 1 plus 2 plus blah 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 is n times n to the negative 1 over 2. So proportional n squared. I guess O of n squared is what people would say. Ugh. So reversing is just one manifestation of general problem, whereas right nested concatenation performs well, left nested concatenation works poorly. Well, that's interesting. So even if we even if we stick this into a list and then recursively call plus 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 in this case, it performs better than reverse would, apparently. I suppose we could test that with criterion, but I'm not sure I feel like doing that right now. But that's what it seems to say. Like even this is what I'm saying, by the way. Apparently, even though these are kind of the same idea, these concatenations behave better in the compiler. I don't know if these literally get yeah. I don't know if these get better by the compiler, but like this is ideal. Okay. Note that in the specific case for reverse, there is an ad hoc solution which uses an accumulator. Oh yeah, so we could fold. So we could do wait, can I do it with fold? Probably can. Let me write the naive way though. Wait, what? Is that right? Is this correct? Whoa. Yeah, I guess we could use those. That would be fun. Why does this feel incorrect? Maybe it is? I don't think it is. It's definitely incorrect. I assume you're gonna say you're saying so our accumulator is an empty list. Oh, right. Duh. I made it so I could write it in a point-free notation, right? That's why I did that. That's the only reason. But for some reason, I wrote it like the book, and I had all the terms back. backwards. So look, the good news is I didn't drop my stream before I ran out of memory. Yeah. Yeah. That's what I wanted to do, but I'm stupid, and apparently I can't do simple Haskell anymore. I think this should be full del. Well, we're gonna get an X. And this is just this. It's flip that. I think. I think that's right. I'm not even sure. Okay. So we take an X off, we put it on. We take an X off, we put it on. We take an X off, we put it on. That's the idea. Right. Beginner Haskell. And by the way, Prutz, literally the next section, well, we have difference lists, which are we've definitely talked about before. Yeah. I mean, it does make sense. It's just tough to think about. Definitely tough to think about. What's up, Oren? Pretzel. You just need a snack? I need a snack too. Okay. Yeah. We're writing I think we like the other one. Sort of. We're talking about the problems with basically left and right concatenation, so that they're motivating how we're going to deal with the slowness of free monads. There we go. I can speak English. My head hurts. That's what we're doing. So this is just motivation for that. Although sometimes you just need to write pretty like boring Haskell. That was a thing that people said multiple days in a row, right? I haven't heard it since then. Just everything in IO. Yeah, I mean this is good stuff. This is good stuff. All right, so I got to remember how this works. Oh, hang on, my cats are locked out. You guys didn't tell me my cat shut the door. That one right there. Hey, Andre, look at me. Hey. Hey. All right. Well, that's what it's like to own a cat if you've never had a cat. They don't actually pay attention to you. But he likes to shut the door and kind of a jerk about it. Anyway. All right, so D-list. Difference list. He wants to close the door. He. That's a he, but the other one's a she. Okay. Not every function is allowed inside the D-list constructor. A compatible function should be one that prepends the D-list data constructor, by the way. All right, so we could have a function toList, which is a D-list celebrity A. Pifsoff for sure. We were talking about Pifsoff today because we haven't talked about it in a while. Strager made fun of my memes, my memes, jeez, my emotes. Then they're not good. I mean, they're just not good. No, get down. So we have a function that takes a list. Yeah, we could start doing that. DL. Why would it take an empty list? This can be a new type. That's what it's saying. Just saying difference list. Why not? I don't know if it matters either. Okay. It's probably true. Probably true. I haven't used quick check or criterion in a while. I did mention it earlier, but it's been quite a while. What's this one do? Which original paper? For D-list? quick check criterion. Which one? So this needs to be. Is it like this? How do I? Excess needs to go. Yeah, but the list needs to go out front, so I guess it's just flip. Yes, but it's point free, right? So this list would be here, but we're writing it in point free because I'm practicing. And we mentioned pifsoff multiple times, so I'm being pifsoff. No, that's okay. To be fair, I didn't have dot when you were saying that, so I was just writing I was writing the wrong thing, essentially. I needed a dot. If I wrote if I didn't have this flip, by the way, it would just append things in the wrong order. Like if I used from list, it would have, you know, the end. It would just flip the list. Whatever was in there would be at the end of the list we ended up with. Oh my goodness. Okay, so our goal was to obtain better performance for concatenating lists. How do different lists help in that respect? We'll consider the case in which you start with two regular lists, XS and YS, which you then turn into difference lists. Well, we didn't write concatenate. Oh, we're gonna write concatenate. Cat D list A. Yes, quick check would tell us we're idiots, exactly. There he goes. Do you see? Watch the door. I don't know if you can hear it. Ooh, yes we are. Actually, you know what we're gonna write? I don't know, can you do this? Is this valid? I don't think it is. Can I would need a symbol that looked like D. Yeah, I didn't think so. Like if we had a delta, we could use delta. Yeah, that's funny. Delay. Door's gonna be shut. It's shut, see? That's the cat. He wants me to be done. Oops. I didn't even see where my cursor was. Yeah. So I always have a problem with the like Greek letters and emojis and that kind of crap in here because I don't know how to type them on my keyboard. Like some people know how to type them on their keyboard. I just don't know how to do it, so I never put them in. And like I was trying to learn how to use pollen in Racket, and you have to use this symbol, like the actual right square, all the time, and like you have to click a button to, you know, put it in the text, and then you have to do it like a million times. So it was just like super frustrating to write the code because I didn't want to type that symbol all the time. Yeah, anyway, I'll just stick to my regular old ASCII symbols essentially. And also, I'm not a big fan of ligatures. I don't understand the point. It doesn't help me. I like monospace fonts. They're fine. Okay, anyway. So by performing this trick, you turn an operation that is linear over the length of the first argument into a constant operation. Yeah, they're just, I don't know. I don't think they're pretty to look at. I think it's actually harder for me to tell the difference between like this and this, because this is just like a box and this looks different than this to me. I don't know. On Jappy's stream, I watch him and I'm just like, I don't like these. They're just not for me. But they weren't made for me, so no big deal. All right, so here's the idea. Why is this nice? Because you've written a function that basically concatenates two functions, and only at like when you concatenate two lists and then you do something like toList, you're only concatenating the entire thing. Like you're putting together the functions and then essentially appending a single empty list. So it's constant time, constant. What do they say? Constant something. Space? I don't know. There was a term here. Just constant operation. Mm-hmm. So that's kind of cool. So we can rewrite reverse. Well, we've been calling it rev. Rev in D, as in difference list, at in D list. I can't even tell the difference there. Triangle plus plus. So this is still going to be A to A, and rev in D list. I don't even know what you're talking about now. I can't tell the difference on my screen, I guess, is all. Classified as a math symbol, not a letter. That's a letter? Well, it's not a letter, I guess. That's the point. Okay. So this is just going to be dot rev prime, where rev prime what is this going to be? I don't even know. Empty. X. Well, we needed D list. So we need to use our concatenate. We need to put X into a D list. So how do we do that? Okay, that's not what I was expecting, but rev prime xs plus 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 plus, super readable, by the way. Come on, clearly a letter. From list X. I guess. So it says, with a simple change of representation, our naive definition of reverse is made asymptotically more efficient. In the case of free monads, we need to do a bit more work to find the right difference representation, but the concept is quite similar. Use a function, like we do in dlist, to represent the operations over a data structure. But instead of a list, we base our construction on the free data type. Yeah. This is obviously append for dlists, and this is obviously append for lists. I don't know how you can't tell the difference. Also, let's do that. Quick format. Make it look nice. All right, so that's it for today. I don't want to keep going. It's a little later than I was expecting. I did start earlier, but then I took a little break and came back. That would be ideal, I suppose, and it's really easy to do. And technically, we'd make it a semi-group, wouldn't we? We could make a monoid as well, because it has a literal definition for empty. Where, and it's really just like. Oh, right. This isn't like functor, so that's it. And then you can write instance monoid dlist a where empty equals empty. And then down here we can just write dupe, and we're done. Good question. I don't think so, but let me look real quick before we end. No, there are no links in there. Maybe there are links in the back of the book, because I feel like I thought that was a thing that was in here. There's like a diving into theory section. Maybe there's something back there, but I'm not entirely sure. But we definitely, I definitely feel like I need to spend some time reading more, or a lot more, about extensible effects. And then I think, I feel like understanding extensible effects means that I also need to understand continuations. And I still don't, I mean, I see how people use continuations, but the logic of when I would start writing continuations, or like the mechanisms that are required to make continuations work in practice, are still a little confusing to me. So I think that those two things, like my sort of lack of understanding continuations, is leading into my lack of understanding of extensible effects. Does that make sense? Yeah. Like if we didn't have continuations, we wouldn't have extensible effects. So it's like you need to understand that before you get to the next thing. So it's like it's really important that I have a good understanding of the mechanisms behind how and why continuations work the way they work in Haskell. As in, why does the continuation monad do what it does? Something like that. if that makes sense. Okay. Anyway, that's it for today. Thanks for hanging out. As usual, thank you, Strager, for like solving my problems all the time. I really appreciate that. That's very nice of you, because I don't know, this is getting hard. This is getting very hard. What other languages have I worked in? So in order: Fortran, C++, Python, Haskell, with random stuff in between that, you know, I didn't spend a lot of time in. I know what continuations are. Like, I know what they are, but there's like fundamental mechanics behind how they fit together when we start talking about like implementing them and, you know, using them in the extensible effects framework that I think that I don't understand. But I'm not sure. Yeah, I mean, I'm into. If you want to send me that tutorial, you can just DM me. Like, I'll read it. That's totally fine. The more the merrier. Uh, my cat's mad because they're locked out again. Um, yeah, I read that one. I'm not sure that it helped me. So, I don't know. Maybe I need to read it again and again and again and again. I did say at one point I was just going to implement the continuations, functor, applicative, and monad until it made sense. Like, I was just going to do that every day until it made sense. I haven't done that, but I probably should.